This is 4.4C homework worksheet. We're going to do number 3, this one. And if I list out all the possible rational roots, well, we know that P has to be an element of, okay, we go from the 4, plus or minus 1, plus or minus 2, or plus or minus 4. And I know the Q has to be an element of, well, the 8. So we go plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. Which means that P over Q could possibly be, well, we have plus or minus 1, 2, and 4. Then we can go 1/2, 1/4, or 1/8. And then we can, let's see if we have any other ones. 2, that's 1, that's 1/2, and 1/4, we already got that. We have 4 over 1, 4 over 2, 4 over 4, and 4 over 8. Okay, so this is it. It's not too bad. I know it looks like a lot, 12 possibilities. It's a 5th degree polynomial. I have to get it down to a 2nd degree polynomial in order to either factor it or use the quadratic formula. So let's list out the coefficients: 8, negative 44, positive 86, negative 73, 28, and negative 4. No zero coefficients, so we're good. And let's start testing. I haven't seen this one in a while, so I really have no idea which ones are going to work, but I tend to test the easy numbers first. 1 times 8 plus negative 44 is negative 36. Negative 36 times 1 plus 86 is 50. 50 times 1 plus minus 73 is negative 20. Then we have 8, and then 8 times 1 plus negative 4 is 4. That did not work, but it gave us a remainder of 4. We're just going to kind of keep that information there. Let's try negative 1. 8 times negative 1, I'm going to kind of speed this up here, 52. 52 times 1 plus 86, or negative 1 plus 86 is 138. That's positive 138, negative 73, so 65. And negative 65 and 28 is, what would that be, 37, negative 37. Then that would be, let's see, positive 37, okay, so that's not helping us. Continuing, let's try 2. If we start with 8, 2 times 8 is negative 16. Negative 16 plus 1 plus 44 is negative 28. Then we have negative 56 plus 86 is 30. Then we have 60, that's negative 13, times 2 is negative 26, so that's 2. Up, and we got 1. Okay, right away we know a few things. First of all, we know that 2 is a 0, and that we're going to start using these as our new coefficients. This is going to speed this up tremendously. We also know that that we now have a limited set of possibilities. We've already tested 1 and negative 1, so those are out. We tested 2. Doesn't mean 2 can't repeat again. But if I look at my possibilities, this kind of as the P would be 2 and 1, and this would be 1, 2, and 4. There's no possible way from this that I could ever end up with the 4 over 1, so that's going to drop out. So I just kind of cut down on my possibilities here, and I'm also given a smaller polynomial to use. So when you find one, your work should start to get a little bit easier. You're going to drive yourself crazy if we try to figure out other roots and then come back to the possibility of a double root. So I'm just going to try 2 here and see if it's a double root, just to kind of keep me from that possibility. 2 times 8, 16. And remember, I'm going with this now as my coefficients that I'm using. So 2 times 8 is 16, plus negative 28 is negative 12. Then we have negative 24, plus 30 is 6. Then we have 6 times 2, negative 1, and lo and behold, we got another one. So 2 is a double root. And just like I said, we would go crazy trying to do other roots and not just test to see if it's a double root. Right away I've noticed that, well, I still have my same possibilities, 1/2, 1/4, 1/8 from this P and this Q. we're going to now shift and start using these as my new coefficients. So let's keep going. Just having a gut feeling, let's try 2 one more time just to make sure that they didn't try to trick me with a triple root. 2 times 8, 16. 16 plus negative 12 is 4. That'd be, let's see, 4 times 2 is 8. 8 plus 6 is 14. So that's 14, and 14 times, okay, so it's not 1, but let's at least finish it. That would be 27. Now we have to kind of keep straight because we crossed out 2. We could try negative 2, but I'm going to try 1/2. 1/2 times 8 is 4. 4 plus 4 is 8. 1/2 times 8. Oops. See, I'm doing what you can't do. I'm using this, and I typically... Okay, let's go back. 1/2 times 8 is 4. 4 plus negative 12 is negative 8. Then we have negative 4. Negative 4 plus 6 is 2. 1/2 times 2 is 1. Okay, and that's 0. Now what I have, if I look at these coefficients, this is 8x squared minus 8x plus 2 equals 0. And I already now have that 2, 2, and 1/2 are roots. So we're just trying to figure out what the remaining ones are. Well, I can at least cut that all in half. 4x squared minus 4x plus 1. And that looks to be a perfect square trinomial. That's 2x minus 1 squared is equal to 0. So x is equal to 1/2 twice, meaning multiplicity of 2, or a double root, but this is actually a triple root because we already had it up here as well. And then 1/2 is a triple root.